We're looking here at inverse matrices and how to find them. First, all we got to do is prove that they are inverses. The only way to do that is by multiplying the two matrices together, A times B. So I'm just going to rewrite them real quick, and then we're going to we're going to multiply them to find what the product would be. So the way that we multiply is by multiplying rows by columns. So what that means is this first entry in the top left is going to be first row times first column, which means 3 times 7, which is 21, and then negative 5 times 4, which is negative 20. So I'm just going to simplify that right now. 21 minus 20 is 1. This entry here will be first row times second column. That's where the answer is. So first row is 3 times 5 is 15, and negative 15, which is 0. We're down here, second row first column. Negative 4 times 7 is negative 28, and then 7 times 4 is positive 28. So that should also be a 0. And then for the last one, negative 4 times 5 is negative 20, 7 times 3 is positive 21, so that adds to give you 1. So what you should be looking for, you better be getting the identity matrix as your answer. Alright, in the second one, same thing. We're just going to multiply them together. So what I'm going to get, first row, first column. So negative 1 times 3 is negative 3, and 4 times 1 is 4. So again, we get 1 as our top left entry. First row, second column. So negative 1 times negative 2 is positive 2. 4 times negative 1/2 is negative 2. So that gives me the 0 that I desire. Here, negative 2 times 3 is negative 6, and 6 times 1 is positive 6. So again, we get the 0 on that diagonal. Then negative 2 times negative 2 is positive 4. 6 times negative 1/2 is negative 3. So that gives you the 1 that you should get. Alright, looking at the next set here. All we should be looking for when we have to determine if they have an inverse, all you should be looking for is, does the determinant equal 0? That's what you should be checking. If it does, then the matrix does not have an inverse. If it's anything else, then there is an inverse. So, to find the determinant, we cross multiply. So, negative 2 times 7 is negative 14. 3 times 4 is 12. We subtract them and I get negative 26. That does not equal 0, so that means that there is an inverse. So yes, an inverse exists. Okay, in number 4, 3 times 4 is 12. Negative 6 times 2 is negative 12. I have to subtract these two numbers. Be careful. Minus negative means plus a positive, so my determinant is 24. So again, yes, I have an inverse for this one. In number 5, very similar. 3 times 4 is 12. Negative 6 times negative 2 is positive 12. Subtract them, and I get 0. So this one, there is not an inverse. There is no inverse for this matrix. In number 6, 0 times 8 is 0. Negative 1 times 7 is negative 7. I subtract them and get 7. Again, it doesn't equal 0. So yes, this one is invertible. There is a matrix. For number 7, okay, big, huge honking number here should be negative 144 minus, well, 0 times 7 is 0. So negative 144 is my determinant. Again, it's not 0. I don't care what it is. So that just means, yes, there is an inverse for this guy. Then this last one, negative 6 and negative 4 is positive 24. And negative 8 and negative 3 is, whoops, not negative 28, negative 24. So that does equal 0. So again, this one does not have an inverse. Alright, for numbers 9 and 10, we need to find the value of x so that the matrix does not have an inverse, that it is not invertible. The only way to do that, same thing, we need to find when the determinant equals 0, because that's when the matrix does not have an inverse. So to do the determinant, it would be 4 times x, and then this guy is 14. So those are being subtracted, and they have to equal 0. So that means 4x would equal 14, which means x would equal 14 over 4, which is the same as 7/2, or that would be 3.5 if you prefer as a decimal. So it is not invertible when x equals 3.5. For number 10, same thing. The determinant needs to equal 0 for there to not be an inverse. So when I cross multiply, x times 2 is 2x, and then 3 times x plus 1, so it's a subtraction in the middle, x plus 1, it has to equal 0. I'm just going to expand it. 2x, distribute this negative 3, so it'll be negative 3x and negative 1. Combine like terms, so negative x minus 1 equals 0. So that means negative x equals 1, or x equals negative 1. So again, that means that the determinant is 0 or when you have, excuse me, that as your number. Except, of course, here, you did exactly what I told you not to do. Distribute that 3 in here. It should be 3x, but that should be a minus 3 right there. Okay, so this should be x minus 3, which means this is positive 3 when I bring it over. So when x equals negative 3 is when I would not have an inverse for this problem. All right, moving on to these little ones, we're going to actually have to find the inverse of each matrix. So here's the key. All you have to do first, take the guys on the main diagonal, flip-flop them. Take the guys on the other diagonal, change their signs. And now, from there, all you have to do, we have to find the determinant. So the determinant here is going to be 27 minus 30, which is negative 3. I need to take each one of these numbers and divide it by negative 3. So I'm going to divide each one of those by negative 3. So that means my final answer here for this top guy will be negative 3. This guy down here will be negative 2. Negative 1, and I can't do 5 divided by negative 3, so I'm just going to leave it as that fraction, negative 5 over 3. Okay, and number 12, same thing. Start by taking your determinant, start by flip-flopping. Let's do that first. Change the signs of the other diagonal. Now we find what the determinant is. The determinant here is going to be 0 minus 2, so negative 2. So I got to divide each one of these guys by negative 2. So I'll give you negative 3, positive 1/2. Positive 1, and 0 divided by anything is 0. Okay, same thing on this guy. We're going to start with flip-flopping the main diagonal. Change the sign of the other diagonal. And now, determinant is negative 21 minus a negative 20. Minus a negative means plus a positive, so my determinant is negative 1. So I need to now divide everything by negative 1. Well, that just means changing all the signs. So this would be positive 3 and positive 5 in the first column, negative 4 and negative 7 in the second column. Okay, in number 14, again, start by changing the location of the main diagonal, the sign of the other diagonal, the determinant, 5 times 10 is 50, 7 times 7 is 49, so that determinant is 1. So that means I need to divide all these by 1. Well, guess what? We already have done that because dividing by 1 means the exact same thing. So that guy is done. Okay, in number 15, same idea. First, change the location of the main, the sign of the others, find the determinant. So I get 5 minus 6, positive 5 minus 6, so negative 1. So I need to divide by negative 1 for all those, which just makes all those numbers from negative to all being positive. And number 16, 2 times 1 is, 2 times 1, wow, I get ahead of myself. Flip the 2 and the 1, because they're on the main diagonal. Change the sign of the other 2, because they're on the non-main diagonal. And now I need to divide by the determinant. The determinant is 2 here for that cross, 4 times 3 is negative 12 for that cross, so that is negative 10. So I need to divide that whole thing by negative 10. Well, none of those are going to go in exactly perfectly, so I'm just going to have them as fractions. Negative 1 over 10. This will be a positive 3 over 10. This would be a positive 4 over 10, which would reduce to positive 2 over 5. And this guy here will reduce to a negative 1 over 5. It would have been 2 over 10, down to now 1 over 5. Okay, in number 17, what I would be doing is flip-flopping the main. So 4 and 25. Negative 10 and negative 10, because you change the sign of the other guy. Now, we have to go then with the determinant. So, determinant here, 25 times 4 is 100. 10 times 10 is 100. So my determinant is 0, so I should be dividing by 0. Well, guess what? I cannot do that. There is no inverse for this one because the determinant equals 0. Because the determinant equals 0, no inverse can exist. All right, the last one here. 6 times negative 1 gives you negative 6 for your determinant. 3 times 2 gives you a 6 for your determinant. So negative 6 minus 6 is negative 12 for your determinant. So we can take an inverse. Remember, I go and I switch the main diagonals, and I change the sign of the other diagonals. Keep saying that in your head. Now I need to divide by that determinant, negative 12. So when I do that, I should get negative 1 over negative 12 just becomes positive 1 over 12. This will become a positive 1 over 6. 2 over 12 reduces to 1 over 6. 3 over 12 will become 1 over 4. And 6 over 12 will become 1 over 2, and that'll be negative, because that's positive over negative. So there is your matrix there for that. Alright, and then what you're going to be asked to do is to take one of these matrices and use row reduction to find the matrix inverse that way. So, I'm going to pick, well, first of all, you don't want to pick 17 because, well, it's not going to have an inverse. Okay? I would also suggest not picking ones that have fractions. So I would say 11 and 12 are ones you probably wouldn't want to do there either. 13, 14, 15, those would be the best ones because we got answers on the last page that all did not equal 0. 13 and 14 are very similar. I'm going to go through numbers 14 and 15 with you, and we'll see how we can do them. Alright, so here are your matrices. Let's start with this first one. What you're going to do, you're going to take this matrix, and you're going to augment it with the identity matrix. And now all you're going to do is row reduce, like we've done many times before. So what I'm going to do, take the top row, I'll multiply it by 7. Take the bottom row, multiply it by negative 5. That'll give me up top, positive 35, 49, augmented with 7, 0. And on the bottom, negative 35, negative 50, 0, and negative 5. From there, I'm going to add the two rows, row 1 and row 2. I'm going to plug it into row 2 to get that bottom guy into a 0 first. So when I do that, I'll have a 0, a negative 1, a 7, and a negative 5. And up top, everything's still the same. 35, 49, 7, and 0. Okay, from here, what I'm going to try to do, I need to try to work my way upwards. Well, I know I can divide all these numbers by something, so I'm going to do that first. Divide that top row all by 7 again to get it back to the beginning. So it would have been 5, 7, 1, and 0. My bottom's still the same, negative 1, 7, negative 5. Now I can multiply this bottom row by 7 so that I have the exact same number here in that second column. So my top will stay the same, 5, 7, 1, 0. The bottom now will be 0, negative 7, positive 49, and negative 35. I can now add them together, row 1 and row 2, and plug it now into row 1 because I need my 0 up top. So I'll have 5, 0 for adding these together. 49 and 1 gives you 50. Negative 35 and 0 gives you negative 35. Bottom row stays the same. And the last step is just to divide. Divide the top row by 5 and divide this bottom row by negative 7. So the top row will be 1, 0, 10, and negative 7. The bottom row should be 0, 1, negative 7, and positive 5. Okay? This part right here that I'm about to highlight, this part here in, well, green, I guess. That part in green, well, I don't like green. Let's make it blue. The part in blue is your inverse matrix. That is your final answer. And actually, if we go back 2 pages, you can see that the answer should have been 10, negative 7, negative 7, 5, which is exactly what we got. So you should be able to check your answer as you go along here as well. Now, we also knew from the other guy, for number 15, we should know that this answer should end up being 5, 3, 2, and 1. That should be what matrix we get to in the end. So we start the same way. We're going to augment this matrix with the identity matrix. Okay, we'll start by, well, I have a 2. I need to get that to a 0. I'll multiply the top row by 2 to make those numbers the same. So I'll have a negative 2, positive 6, 2 and 0 up top, keeping the bottom the same. Okay, I can now add my 2 rows together, row 1 and row 2, plug it into row 2. When I do that, top's still the same. Bottom should now be negative 2 and 2 is 0, 6 and negative 5 is 1, 2 and 0 is 2, 0 and 1 is 1. Okay, from here, I still need to get now the top part into a 0. So, to do that, I need to multiply this bottom row by negative 6. That way I have the same number. So my top is still the same. My bottom is now going to be 0, 1, actually negative 1, sorry. Negative 6, sorry. 1 times negative 6 is negative 6. 2 times negative 6 here will give you negative 12. 1 times negative 6 gives you the negative 6. Now I can add my 2 rows together. And I'm going to plug this time into row 1 because that's where I need to get my 0 is up at the top. So, my top will now read negative 2 and 0 is negative 2. 6 and negative 6 gives you 0. 2 and negative 12 gives you a negative 10. And 0 and negative 6 gives you negative 6. Bottom guy saying the exact same that we just had. Okay, and the last step is just to do your division to get those leading entries into a 1. So I'll divide by negative 2, divide by negative 6 on the bottom. So my top line should be 1, 0, 5, and 3. My bottom one should be 0, 1, 2, and 1. And again, this part that I'm about to highlight here in blue is your inverse matrix, and that's exactly what we were looking at here and what we were expecting to get. So you're going to have to row reduce one, and you're even going to get to pick which one you like the best to try to do. There you have it. Best of luck. Take your time. And remember to answer the question you're asking. You don't need to find the inverse matrix unless it absolutely says you have to. Otherwise, just look what it's asking for. If it's saying to just prove if there is one, if there isn't one, just find the determinant. Just make sure you answer the question that's being asked.